Welcome, everyone, and thanks for taking the time to join us today for the very first o²S²PARC webinar. My name is Katie. I'm an application engineer for the ETIS Foundation. You might have also heard of us called the SIM Core from the Data Resource Center of SPARC, and we're the creators of o²S²PARC platform. I assume that most of you are involved in the SPARC program in some capacity, so you may have already heard about our platform through the NIH communications, but perhaps you haven't really looked into it or understood how you can benefit from using it. So that's mainly what we want to discuss today. What is o²S²PARC? What can it do? And why should you care? Just to start off, I'll just briefly introduce us, the ETIS Foundation. We are a nonprofit research foundation that's closely affiliated with ETH Zurich, the university, and we were established originally to develop electromagnetic near-field sensors, exposure evaluation methods, and investigate the interaction between EM fields and tissues. So here's a list of some of the most common types of research that we have been involved in regarding EM fields and neural interaction modeling. Because of this existing experience with these areas and their significant overlap with SPARC's goals, we were tasked with creating a suite of tools to enable SPARC researchers to do the same, which brings us to what is o²S²PARC? One of the burning questions you might have had about o²S²PARC is probably what that acronym is with all the superscripts. Well, what we wouldn't do for an acronym. o²S²PARC stands for Open Online Simulations for SPARC. It's an interactive online platform for modeling the peripheral nervous system neuromodulation and stimulation applications and its impact on organ physiology. What we want to do is support SPARC researchers in their quest to understand how stimulation of the peripheral nervous system can affect these end organs. Towards this goal, we're providing a platform for you to develop, execute, validate, document, certify, store, and share predictive models for hypothesis testing purposes. We want to emphasize that this is supposed to be a bidirectional platform to foster collaborations within SPARC. So we want you to be able to submit your code, but also to give you resources that other SPARC researchers have created for you to share. Now, what kinds of computations are we talking about? I've been very vague so far, and this was kind of intentional because we try to support as many different types of code as we can. We have a variety of tools that are readily available through the platform, and they span many different areas. Let's start with CAD modeling here at the bottom right. So we support right now an open source 3D viewer and editor on o²S²PARC called ParaView, where you can view, create, or edit custom geometries, and we're even developing our own 3D modeler that will allow you to apply post-processing and filtering to those 3D models. Feeding into this modeler, the ETIS Foundation provides a human anatomical model with peripheral nerve traces, organs, and muscles, and this can be used as an integration sensor for different types of simulations. And you can access this directly on our platform. Next, we support simulations, which can be code projects contributed by other researchers to simulate a specific system. For example, one simulation that we have available from Matt Ward's lab in Pittsburgh is a cardiac action potential simulation. These simulations can be submitted in any programming language in any environment. So for example, MATLAB, R, or Python. Next, we also have visualization tools hosted on the platform. We support traditional plots, charts, and tables, as well as 3D viewers. And you can even submit your own custom visualization tools that will adjust to your specific needs. Finally, we have data analysis. These tools are the most generalized of the ones I list here because they really can be anything. They give you a lot of freedom to run, for example, statistical analyses, post-processing, and integrate well between different nodes. They can be implemented, again, in any language and in any environment. By now, I'm sure you're completely blown away by the platform, but just to give you a few concrete reasons to use o²SPARC, we put together this list as more or less our sales pitch. First, if you're SPARC financed, the NIH is probably going to make you use o²SPARC. But that's okay, because in my completely unbiased opinion, o²SPARC is awesome. As I mentioned before about the bidirectionality of the platform, you can access workflows that are the result of painstaking work by other SPARC researchers. We already have model simulations and computational resources available, and we're hoping that as more and more people contribute their code, the more resources you're going to be finding on our platform. As a contributor, it will allow you to preserve and version your models in their current state. We package your code in their native software environment, so you don't have to worry about software dependencies. Next, you can share your work with your collaborators or even on your own team without having them install anything. Then, cloud-based computing gives you access to these computational resources that you may not have in your local machine or may not want to occupy your local machine with using. Additionally, when you share your work with your collaborators, they won't have to be using their own local resources in order to run your code. Because there are just so many reasons to use o²SPARC, we have another slide. In addition to the other factors that I've mentioned before, o²SPARC also provides a GUI for your code so that it can be a module that is consistent with the other ones that other SPARC researchers may have submitted. You can expose just the parameters that you want users to be able to edit without having to program this GUI yourself. Nodes, or these pieces of code, can communicate with other nodes by passing files, which is supported by all nodes. Next, it could be very useful for a grant application where you can link your analysis pipeline or any kind of model for reviewers so that they can reproduce it on their home computers. Finally, models come with a DOI, so they can be cited by others, and you can make sure that your rat colon motility in response to vagus nerve stimulation model gets the recognition that it deserves. And the most important factor of all is that we are trying to make sure that you can continue using the tools and approaches that you're used to by using the same programming languages and the same environments that you are already using without having to reprogram anything else. So how does this magical platform work? Here, I'll just go through all of the steps that happen from a code submission to its integration in o²SPARC as something that we call a node. A node is just anything that performs some sort of function. So that could be a simulation, could be a visualizer, it can be some sort of data analysis code. And essentially, it's a reusable module that anyone can take and plug into their own computational pipeline. To start this transformation, imagine we have a data wrangler who has a piece of code that they want to submit onto the o²SPARC platform. So they're going to submit it through an easy-to-use form. It's going to be sent to us for curation. We basically want to make sure that the code does what you say it's going to do. After that, it's going to be injected into something called a Docker container. And this is something that is very much like a virtual machine. Its operating system is emulated, and the dependencies for the code are installed to ensure that the environment that the code lives in is going to be reproducible. After that, we version this Docker image so that we can go back to it in case something changes later. So if you do a change in your code, you can create a new version and people will still be able to access previous versions. So in case that they created an analysis pipeline that depends on a very specific version of your code, they will still be able to access any specific version so that their stuff still works. These versions are going to be cataloged inside something called a service catalog that another SPARC user may be able to access, and then take that and plug it into their own study pipeline. Inputs to this study pipeline could be from a user upload. It could be already on our o²SPARC platform. We have a few data sets ready to go, or they can be pulled from Blackfin. another SPARC resource that you might have heard of or maybe are already using. These study pipelines are then executed on our in-house resources or on Amazon Web Services. Once that study pipeline is finished, you can download the results down to your personal computer, or you can push it out to Blackfin. Or what you can do after it's done running is to save your study pipeline as something called a template study that you can again share with other SPARC members. By now, we've discussed a lot about how o²SPARC theoretically works, so it's time to show you what it looks like in practice. For that, go over to my browser to o²SPARC.io. Now here's the landing page where you're going to enter your email address and your password, which you will get if you ask us for a registration link. For now, it's invite only, but in the future, we want to make sure that this is going to be publicly available. Once you log in, you'll see something called your dashboard. Here on the bottom are all of these template studies that other SPARC members have contributed. On the top here are the studies that you have created yourself. Now, if you are logging in for the first time, this first area under my studies is going to be empty. Here, I'm going to demo a few of the studies that we already have. For example, a cardiac model that was contributed by Colin Clancy's lab. So if we go into it, on the very left, we have a file picker, which basically takes in a data file. Next, we have several computational nodes, which take the data and do some sort of transformation with it. And finally, we have several custom viewers that are plotting very specific things that the contributor wanted users to be able to see. Since this computational pipeline takes a while to run, I already pre-ran it. And so what we can do is look directly at the outputs. As I said, this is a custom plot, which is specific just for this model and simulation. Here's another one, depending on the outputs of the computational model. Over on the right here, we see a list of all of the nodes that exist in our pipeline, as well as some metadata about what this pipeline is supposed to do. At the bottom on the right is the logger, which shows basically what is happening when you're running the computational pipeline. Since I ran it before, you're not going to see any updates for the moment. Another one I want to show you was contributed by Matt Ward's lab. This one is a standalone service, which is a bit rare in the sense that it doesn't connect from any inputs and doesn't connect to any outputs. But of course, this could change. You can plug it into your pipeline and have the output go to some other kind of viewer. When you enter into this, this was submitted as MATLAB code at the very beginning, which we took and integrated into o²SPARC. On the top, you can select the input data, load it, wait for a bit, and now predict the compound action potentials. Again, this is a custom GUI that was contributed by Matt Ward himself and adapted by us to be viewable and interactable on the o²SPARC platform. Finally, I want to show you a Jupyter Notebook service, which has an input as well as a Jupyter Notebook node. here we have a demo notebook, which tells you also a bit about how you can take inputs into your code. So for example, how you're supposed to map your inputs and also how to get your outputs. As I said, you can start scripting directly inside here. And run it directly. This is not subliminal messaging at all. Now, what does it look like if you want to create your own computational pipeline? So double click here, and you can already select from the many nodes that we have available. So this is a file picker, which allows you to upload your own file or select one that's already available on the o²SPARC platform. You can connect it to another computation. For example, the Jupyter Notebook. Map the inputs and outputs and do some sort of transformation on the data. Now, this has been a very brief overview of the capabilities of the o²SPARC platform, but we just wanted to give you a taste of what it is capable of and what you can use it for. In the next webinars, we're going to have a lot more in-depth information about how you can actually use it and how you can submit code, how you can get code, and how you can run the models that you have or other SPARC members have contributed. I have a list here of a bit of the vocabulary that I've used for reference for later. First is the login page, which is the entry point of o²SPARC. If you want an account to play around with, and who wouldn't, you can request an account from us by emailing support@o²SPARC.io. Next, the dashboard is what you see when you first log in. It shows you your own studies as well as the public and shared template studies. Your studies are the ones that you have created, and you can revisit them or modify them. Every time you log back in, you have access to your studies from the moment that you left them the last time. Template studies are the published and shared pipelines that other people have created and are allowing the public to use and re-execute. A node is a component of a pipeline that does some sort of function and is reusable inside another pipeline. Now, this again was intentionally vague because it really can be almost anything. It can be a simulation, it could be a model, it could be some sort of data processing, it could just be a file loading node. And finally, the workbench, which is the interface that you use to set up, modify, and execute your pipelines. Here are some resources that you might want to consider using if you're interested in o²SPARC. Again, you can request an account from support@o²SPARC.io or really request general information or any questions. You can find some documentation for the online platform at docs.o²SPARC.io. This one contains some of the vocabulary that I just mentioned earlier, and it also will have some walkthroughs to guide you through how to start using your first template study. Finally, you can find our open source repository on GitHub and submit bugs or feature requests at github.com/ethysfoundation/o²SPARC-SimCore. With that, I thank you very much for your time. And if you are continuously interested in all the resources that you can access from SPARC, you can learn about future webinars and tutorials at sparc.science/news and events. Thank you again, and see you next time.